Hi there. This video is an exam paper walkthrough of the AQA GCSE Mathematics Foundation Tier Paper 2 from summer 2023. This paper is worth 80 marks in total, and this is the third video of 4. It will focus on questions 12 to 17, which account for 15 of these marks. AQA Paper 2s are calculator papers, so a calculator should be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 12. Kai says that 3 to 2 is an equivalent ratio to 9 to 6. Joe says that 1.5 to 1 is an equivalent ratio to 9 to 6. Who is correct? Tick one box. So the options that we have are both of them are correct, only Kai is correct, only Joe is correct, and neither of them are correct. And it wants you to give reasons for your answer. Now, when it says give reasons, it doesn't necessarily have to be a worded sentence. You can just show some kind of working out that shows why you've picked the option you pick. So they think that 3 to 2 is equivalent to 9 to 6. So let's see. 3 to 2. Okay, so if I was to multiply 3 by 3, I would get 9. With ratio, we have to do the same to both sides. So if I multiply 2 by 3, I get 6. So Kai is correct. Now we need to see if Joe is correct. So we're starting with 1.5 to 1. We're going to see if we can get it to 9 to 6 by multiplying both sides by the same thing. So if I double both sides, we get 3 to 2, which is what we started with here. So now then, if I times by 3, we get 9 to 6. So Joe is correct as well. So I'm going to tick the both of them option. So both were correct. Question 13. 28 is increased by 25%. 40 is decreased by 15%. Which answer is bigger? Show how you decide. So what I'm going to do is I'm going to increase 28 by 25% and I'm going to decrease 40 by 15% and then compare the answers. So if I'm increasing by 25%, I want 100% plus that additional 25%. So I want 125% in total. 125% as a multiplier is 1.25. So that's the multiplier I'm going to use to increase 28 by 25%. So if I multiply 28 by 1.25, it's a calculator paper. Gives me an answer of 35. So now I'm going to decrease 40 by 15%. So if I'm decreasing by 50%, I'm going to do 15%, sorry. I'm going to do 100% take away 15%. Well, 100 take away 15 is 85. So I'm looking for 85% of 40 because that will be 40 decreased by 15%. 85% as a multiplier is 0.85. So that's what I'm going to use to decrease 40 by 15%. So 40 multiplied by 0.85, again, it's a calculator paper, is 34. So now I need to compare them. Which is bigger? 35 is bigger than 34. So 28 increased by 25% is bigger than 40 decreased by 15%. Question 14. Factorise 12a, add 15b. So factorising is the opposite of expanding brackets. When we expand brackets, we get rid of the brackets. When we're factorising, we're going to put brackets in. And to put a bracket in, we need to find the highest common factor of 12a and 15b. Okay, so the highest common factor of 12 and 15, I think, is 3. 12 divided by 3 is 4, 15 divided by 3 is 3. There isn't another number that I can divide them both by. So I'm going to pop 3 on the outside because that's my highest common factor. The A and the B are different letters, so we can't include them in the highest common factor. So it's just 3 on the outside. And now I need to divide each of these terms by 3. So 12A divided by 3 would leave me with 4A. 15B divided by 3 would leave me with 5B. So that is my answer, 3, and then in brackets 4A plus 5B. Question 15. Write down all the integers that satisfy the inequality -3 is less than or equal to x, which is less than 2. Okay. So, integers is the important word. We only want whole numbers. Okay, so we only want whole numbers for this. Now, this symbol, less than or equal to, means we can include the -3 in our list. So we're going to start with -3, and then we're going to count along towards 2. So -2, -1, 0, and 1. Now, before we include 2, we need to check the symbol. This is a less than symbol, not a less than or equal to, so we're not going to include 2 in the list of integers that satisfies the inequality. Question 16. A linear sequence starts 7, 10, 13, 16. Work out an expression for the nth term of the sequence. So the first thing we're going to do is see what we're doing to get from one term to the next. So to get from 7 to 10, we add 3. 10 to 13, we add 3. 13 to 16, we add 3. So the sequence is going up by 3 every time. This tells us that it's a linear sequence like it says in the question. So we're going to start by writing 3n. And then we're going to compare this 3 to the first number in the sequence. What do we do to get from 3 to that first number 7? Well, we need to add 4. So our nth term is 3n plus 4. You can double check your answer. So if that's the first term, this is the second term. If we're to find the second term, 3 times 2 is 6, plus the 4 is 10. So we've double checked that our nth term rule is correct. Question 17. Jess saves 2p, 5p and 10p coins. She has 45 10p coins, 8 times as many 2p coins as 10p coins, and £17.70 in total. Work out the total value of 2p coins to the total value of 5p coins, giving your answer in its simplest form. Okay, so we have 45 10p coins. So 45 times 10p is 450p, which is £4.50 in 10p coins. She has 8 times as many 2p coins as 10p coins. So if she's got 45 10p coins, 45 times 8, remember it's a calculator paper, is 360. So Jess has 362p coins. So 360 times 0.02, that's the pound equivalent for 2p, is £7.20. So we know that there's £4.50 worth of 10p coins, £7.20 worth of £2 coins, 2p coins, sorry, and we're dealing with a £17.70 total. So £4.50 plus £7.20 is £11.70. So if I subtract that from £17.70, that leaves me with £6 that will be in 5p coins. Now, we don't need to know how many 5p coins. It just wants the total value of 5p coins and the total value of 2p coins. So this is our total value of 2p coins, and this is our total value of 5p coins. So we're going to write it in a ratio the value of 2p coins to the value of 5p coins. So it'll be £7.20 to £6. And then we need to give our answer in its simplest form. Ideally, we don't want decimals in a ratio, unless we're writing it in a different form. We don't want decimals in this ratio. So what I'm going to do is divide by 1.2. So 7.2 divided by 1.2 is 6. And 6 divided by 1.2 is 5. So the answer is 6 to 5.